Okay, welcome to the session on association. So, this session the objective is to discuss association between random variables. Now, if the random variables are nice quantitative variables, we can think of association in various ways. In those cases, we generally quantify the association in terms of what is called as correlation coefficient. Financial world measures what is called as covariance or co-movement, but those are typically done for quantitative variables, right, the interval variables and so on. What if we are not talking about those interval variables or ratio variables? We are talking about categorical variables. How are we going to measure the association between categorical variables? Now, what are categorical variables? If you recall, variables are essentially categorical or ratio or interval, right. Remember, there are 4. So, categorical variables themselves can be classified as 2, right, when the categories can be organized in a particular sequence and when the categorical variables cannot be organized in a particular sequence. Gender, for example, is an example of a categorical variable which cannot be arranged in a particular order. Whereas the ratings that we give, ratings that a customer gives to a restaurant, for example, the food in a restaurant was very bad, bad, neutral, good, very good. Now, this is a data that is organized in categories, but the categories can be ordered, right. So, you go to a restaurant and we have this experience very common. At the end of the meal, the person hands over a tablet nowadays, where we have to record our feedback about the service in the restaurant, about the quality of the food and so on and so forth. So, there generally the categories are the food was very bad, terrible, it was bad, I was neutral about the food, right. Generally this is called something else, they polish it and say it's something better. The food was good, the food was very good, right. Sometimes the category names may be different, right. Sometimes they will say they will only start with bad, average, very good and excellent, right. So, this is an example of a categorical variable which can be ordered. So, this kind of variable is called ordinal data. Okay. So, what is the variable here? The variable is food quality. This is the variable. The variable is food quality, and this variable food quality can be categorized in 4 ways: bad, average, very good, excellent. Or the variable food quality can take which values? Very bad, bad, neutral, good, very good. So, 5 possible values or 4 possible values. But here there is a natural ordering of the data, right. Therefore, this data is called ordinal data. The categories can be ordered. You are not going to put very good, bad, average and excellent. So, you are not going to put categories in a haphazard manner. There is a natural ordering. Whereas, there are other categorical variables where the data cannot be organized in a particular sequence. As I said, gender, right, or let us say that you have businesses in 18 different countries. Now, the country as a variable can take on 18 different values. I have offices in US, France, Brazil, India, China, Australia, New Zealand. Now, you can say that I will arrange the cities in alphabetical order, fine. You can arrange the cities in the order in which you opened your offices, that is also fine. So, there is no natural ordering there. You can decide the ordering and any ordering is okay, right, but usually there is no ordering. You can't say New Zealand should always be 1 and USA should always be 3. You can't say that, right, and you can put any cities after any cities before any city. So, there is no natural ordering there, right. So, those are also categorical variables. What we are going to discuss today is association between these kinds of categorical variables. Now, in particular, we are going to split the discussion in 2 parts. One is called determining the association and the other one is called inferring the association. Now, what do I mean? These are not very standard terms. So, these, let me say that what do I mean by determining and inferring? Now, if a data is given to us, some sample data is given to us, how do you determine that the variables are associated? That is a different question. However, we are actually interested in a bigger question. The data that we are going to determine association about is going to be only a sample data. Usually, we want to infer about the population. So, this problem is about the population, right. So, once you determine that there is some association, how can you extend that to the population? How can you generalize those insights to the entire population? That problem is the inferring problem. So, let us first understand how do we determine or how do we quantify association between random variables from a sample data, and then we extend that to the insights to the population in terms of inferring about the association. Okay. So, let us take an example. Let us take example of determining the association, and this will also determining the association between categorical variables will also help you recall the discussions on conditional probability. So, if you want to pause the video and do a refresher on conditional probability, that will be a good idea. Does not matter, we are going to discuss conditional probability in this session also. We are going to use conditional probability to determine association between random variables. So, let us proceed. As I said, let us proceed with an example. So, let us take an example from a business school. This is cooked up data. The data that I am going to show is not real data. Let me put a strong qualifier because this the example that I am taking is slightly sensitive, but let me tell you that this is purely cooked up data. Okay. So, let us say that a B school, a particular B school, fake B school, let us say, has shortlisted about 1200 candidates, 960 male candidates and 240 female candidates for a postgraduate management program, right. They are shortlisted. So, after that there will be an interview session and so on, and out of these 1200 candidates, after the round of interview and so on, 324 candidates were given the offer letter for admission. 324 candidates were selected. Now, some of these 324 may be male candidates, some of them could be female candidates. So, let us understand the details of this data. So, what is the data? This is the data, right. So, there were totally 1200 candidates who were shortlisted. Out of that, 960 were male candidates, 240 were female candidates. Out of the 1200 candidates who were shortlisted, they were interviewed, they were given some other tests, and after all these tests and selection process criteria, 324 people were offered admissions. Okay, admissions offered. 324 candidates were offered admissions. 876 candidates were not offered any admission to the postgraduate management program. Okay. So, once again this is a toy example. This is a data that I created. This is not real data. This has nothing to do with any B school. This is nothing to do with any B school. This is not real B school data. This is just a point to drive my point across, drive the concept across. So, generally this kind of table is called contingency table. Okay. So, now what happened was essentially what happened out of these 324 candidates, only 36 candidates were female candidates, 288 candidates were male candidates, right. Out of this 324, 288 were male candidates and 36 were female candidates. So, looking at the data, the Women's Forum for example said that yeah, this is a case of gender discrimination, right. You say that only 36 female candidates were offered admissions and 288 male candidates were offered admissions. The B school responded saying that well, this happened purely because there were more male candidates who were interviewed than female candidates. So, obviously, the number of selected candidates will have more male candidates than female candidates. So, the B school, so yeah, as I said, this kind of table is called contingency table. Okay. So, B school responded that there is no discrimination here. This purely happened because there were fewer female candidates who were shortlisted, and therefore, they appeared for the selection process. Now, how are we going to, as a data analyst, how are you going to analyze this data? Few things to be noted about this data. Once again, this data is toy example data. This is not real data. What else? You note that this 1200 is not the population. This 1200 may be sample from the entire list of candidates. So, you cannot generalize anything from this sample. This is sample data. This is sample data. Entire population may be much bigger, right? We may be looking across the B school, we may be looking across the years. So, maybe population size is much bigger, or even for this management program, the population size may be bigger. We have data about 1200 candidates. Based on the data about 1200 candidates, what are we going to conclude? Are we going to say that women's forum may have a point, or are we going to say that B school's argument may be correct? To do that, as I said, we are going to look at this problem from the perspective of conditional probability. Now, what are the events here? What are the events here? I can see 4 events. So, let us define the event more generically. What is the probability that a randomly selected candidate is a male candidate? Let that event be M. What is the event of randomly selecting a female candidate? Right. Let that event be W, women. Right. Now, let us say that there is an event of admission offer being made. Let that event be called A. Right. What is the event of randomly selecting a candidate for whom admission offer was made? And obviously, let us call this as N. This is the event where a randomly selected candidate, the candidate may be male, female, a randomly selected candidate is not offered admission to the program, right. So, these are the 4 events. Let us list them down, right. So, let M be the event that a male candidate, the candidate selected is male. F be the event that a candidate is a female, right. Okay, F, W, you can use both. Let A be the event that candidate is offered admission, the randomly selected candidate is offered admission. Let A complement be the event that the candidate did not get any admission offer. Now, what is this AC? AC is called the complement of event A, right. Go back, there are only 2 possibilities, right. There are only 2 possibilities. So, either the person is offered admission or the person is not offered admission. So, if this event is A, you need not call this event N, you can actually call this event A complement, because there are only 2 possible options. Either the candidate is offered admission, either the candidate is not offered admission. Okay. So, that is why we do not waste notation, we can simply use A complement, right. We can simply use A complement to denote the event that the candidate is not offered admission. Obviously, the probability of event A plus probability of the complement event A complement has to be equal to 1. This is from the axioms of probability. Now, what are axioms of probability? Go back and review your session on probability. You must have studied axioms of probability before. So, these are the 4 events, right. Now, you look at the table, right, these cells, for example, 288 represents not a single event happening. 288 actually seems to be combination of 2 events. What is the combination here? What is it combination of? It is the combination that the candidate is a male candidate and he is offered admission. This 36 is a combination of 2 events. What are the 2 events? The 2 events are, first event is the candidate is a female candidate, and this is also the candidate who is offered admission. So, simply defining these events may not be enough. We actually need combinations and other events also, right. Let us define those also. Okay. So, what we are going to do is, yeah, the probability that a randomly selected candidate is a male and offered admission, this is, so as I said, this is a combination, right. First of all, the candidate is a male candidate and, right, and so this is a new event and is offered admission. So, this is this kind of a combination is called joint event, and this probability is called the joint probability. Okay, joint probability. Joint probability is the probability of the candidate being male and offered admission. If you recall, and was this notation, okay. And as we have seen earlier, how do you read the data about it? How do you read this combination data? This combination data is from our contingency table, this 288, this 288. So, what is the probability of these two events happening together, the candidate being a male candidate and being offered admission? What is the probability of this happening from the data? It is going to be 288 divided by 1200. Similarly, the joint event of candidate being a female candidate and the candidate being offered admission, right, this is the frequency 36. There are 36 candidates who are female candidates and have been offered admission. So, what is the probability of these two events happening together? That will be 36 divided by 1200. Similarly, you can define 672 divided by 1200 to be a joint probability. You can define 204 divided by 1200 to be a joint probability, right. So, those are the 4 joint probabilities. Okay, those are the 4 joint probabilities. Similarly, as I said, the joint probability that a randomly selected candidate is a male candidate, but and he is not offered admission, right. So, this is a combination of 2 events. Candidate is a male candidate, which is this event M, and is always this notation, and the candidate is not offered admission. Just like you use the notation A for the event of admission offered being made, you are going to use a notation A complement for an event that admission offer was not made, right. And this combination has a probability of 672 divided by 1200, which is 0.56, right. As I said, for the other two, right, right. Obviously, this should be F or this should be F, right. From the previous slide, this should be F, or I can change that F to W. So, 0.03 is the joint probability that the candidate is a female candidate and she is offered admission, right. That is probability 36 divided by 1200. The probability that the candidate is female and she is not offered admission, that probability is 204 divided by 1200, 0.17. This is from the data. So, these are called joint probabilities. Okay. These are called joint probabilities. Going back to the table, these are called joint probabilities. So, these 4 numbers, right, these 4 numbers 288 divided by 1200, 36 divided by 1200, 672 divided by 1200, 204 divided by 1200, these are called joint probabilities. Joint probability. Now, let us read from the column. Now, for a male candidate, there are only 2 possibilities. Either the admission is made or the admission is not made, right. So, 288 male candidates are offered admission, 672 male candidates are not offered admission. Totally, there were 960 male candidates who were shortlisted. Now, what do you call this 960? If this 960 is the frequency of a randomly selected candidate being a male candidate. Okay. So, then let us go further. Okay. Let us go further and calculate this probability as 0.8. What is this 0.8? This 0.8 is called marginal probability. Marginal probability, right. So, marginal probability is this 0.8 was obtained as 960 divided by 1200. What is this probability of? This is the probability that a randomly selected candidate is a male candidate. Okay. Similarly, probability that the randomly selected candidate is a female candidate, that probability will be, what will be that probability? It will be 240 divided by 1200, and from the table you know that this is 0.2. Similarly, what is this 0.27? 0.27 is the probability that a randomly selected candidate has been offered admission. Okay. So, this is the probability that event A has happened. This is the probability that event A has happened. The admission offer has been made, right. How many people were offered admissions? How many people were offered admissions? Let us go back to our contingency table. 324, right. So, what is the probability that a randomly selected candidate would be offered admission? The candidate may be male, female, right now we are not interested in that. And a randomly selected candidate will be offered admission with a probability 324 divided by 1200. There are 1200 people who are shortlisted, out of which 324 candidates have been offered admission. So, what is the probability that a randomly selected candidate will be offered admission? That will be 0.27. Okay. The remaining people will not be offered admission. Remaining people will not be offered admission. So, probability that event A complement has happened. What is the event A complement? Event A complement is the event that candidate, a randomly selected candidate is not offered admission, right. So, that is 876 times this has happened in the data. Out of the 1200 data, out of the 1200 candidates, 876 candidates were not offered any admission, and therefore, this will be 876 divided by 1200, turns out that this is 0.73. Now, these values 0.8, 0.2, 0.27, 0.73, they are called marginal probabilities. Easy way to remember this is to say that they are appearing in the margins, they are row totals and column totals divided by the total 1200, right. So, they are called marginal probabilities. So, now we have described two kinds of probabilities from our contingency table. These 0.24, 0.03, 0.17, they were called joint probabilities, and these 0.8, 0.2, 0.27, 0.73 are going to be called as marginal probability. Marginal probability of this event happening, or this event happening, or this event happening, or this event happening, those are the corresponding numbers. Okay. I hope you are with me, otherwise you can pause and go back again, right. But this is discussion on probability. Where are we on answering the question, right? Where are we on answering the question? This was the question that we need to answer. Is there enough support for some bias happening in the admission process, right? Now, for that, what we will do is we will calculate this probability. Now, what is this probability? What is this notation for? This is a notation for conditional probability. Remember, this is different from joint probability. Joint probability was denoted by this notation, where we use and, right, M and A, F and A, or W and A, right. So, this is the notation for joint probability, and notice the difference. This is a different notation, right. So, this is a notation for what is called as conditional probability. So, what is this probability? This is the probability, this is the probability, right. This is a probability. So, there is a vertical line here. How do you read this notation? This is you read this notation as the probability of event A happening given the fact that event M has already taken place. Let me repeat that. This is the probability that event A, this is the probability of event A happening given the fact that event M has already taken place. This is different from, once again let me tell you, this is different from joint probability. What is joint probability? Joint probability of event A happening and event M happening at the same time. Conditional probability says event M has already taken place. Okay. You already know that the candidate is a male candidate. Now, you are trying to find the probability of somebody being offered admission when the candidate is a male candidate. The event M has already taken place. Okay. So, how do you calculate that probability? Now, you know that you want to understand only the admission status of the male candidates. So, how many male candidates? 960 male candidates. Out of that 288 were offered admissions. So, if you want to understand what is the probability of admissions when the candidate is a male candidate, that can be calculated by doing this 288 divided by 960. So, what are we saying? Everything hinges on the contingency table. So, we go back to contingency table. So, we are saying the candidate is already a male candidate. So, we are not worried about the rest of the table, right? We are not worried about the rest of the table. Can I erase this now? Let us erase all this. This is only for explanation. So, let me erase, keep the contingency table clean. Now, let me say whatever was there on the contingency table. Now, we are saying that we are interested only in this column. Why are we interested only in this column? Because we are saying event M has already taken place. We already know that the candidate we are talking about is a male candidate. So, candidate can only be 1 out of the 960. So, we are not talking about the entire sample size of 1200. We are now restricting ourselves to only one of these 960 candidates. Now, how many of these 960 candidates are offered admissions? 288. So, what is the probability that somebody will be offered admissions given the fact that they are a male candidate? The very fact that they are a male candidate, I am going to look at only these 960. And then what is the probability of somebody being offered admissions out of this 960? 288, and therefore, I am going to calculate that probability of somebody being offered admissions given the fact that the candidate is a male candidate. Okay, that can be calculated simply by looking at this column only, 288 divided by 960. So, this is called conditional probability. You can do the same thing for female candidates, right? You can do the same thing for female candidates, right? Let me ask you this question. What is going to be the probability of admissions given that the candidate is a female candidate? Now, how many female candidates? 240 female candidates. So, you are going to restrict your discussion only to these 240 candidates. Out of these 240, 36 were offered admissions. Therefore, this conditional probability is going to be calculated as 36 divided by 240. Okay. So, this is conditional probability, which is different than the joint probability. Okay. Now, how you can also get this 0.3 in different ways. How do you get this 0.3 in a different way? You can get 0.3 as 288 divided by 960. Okay, 288 divided by 960, you will get your 0.3. You will also observe that this 0.3 can be obtained in a different way. This 0.3 can be obtained as, so you divide, you are trying to get 288 divided by 960, you divide both numerator and denominator by 1200. Okay. So, you divide the numerator and denominator by 1200, you will get 0.24 in the numerator, 0.8 in the denominator, and you will get back your 0.3. Where is this 0.24 and 0.8 in our table? That is in this table. So, how are you reading? How are you getting your 0.3? You are getting your 0.3 as 0.24 divided by 0.8. That is what you said, right? That is what you said, right? That is what we said. So, 0.3 is 0.24 divided by 0.8. However, what is this 0.24? What does this 0.24 represent? You already know what this 0.24 represent. This 0.24 represent joint probability. It is joint probability. So, what is this? This is a joint probability. What is this 0.8? 0.8 is a marginal probability. What is this 0.3? We said this 0.3 is a conditional probability. Okay. And that is how you get your method for calculating conditional probability. Conditional probability is always calculated as the ratio of joint probability divided by marginal probability. Say that again. Conditional probability is always joint probability divided by marginal probability. Now you can do the same thing here, right. So what will be this? What will be 0.03 divided by 0.2? What is this? 0.03 is a marginal probability. So this is, sorry, 0.03 is a joint probability divided by 0.2. 0.2 is a marginal probability, and obviously 0.03 divided by 0.2 is going to be a conditional probability. Let us go one step further. This 0.3, this 0.24, this 0.24 comes from what joint probability? What is the joint probability of? It is the joint probability of the candidate being male and admissions being offered. Remember, this was the notation that we used, right. This was 0.24, two events happening together, the candidate being male and the offer of admission being made, right. So 0.24. So this is the joint probability of M and A. What is this conditional probability? We saw that this is the conditional probability of A given M. So this is the conditional probability of A given M. And what is this 0.8? This 0.8 is a marginal probability, that the candidate is a male candidate. Sorry. Is a male candidate. Okay. So now you know the equation. What is the, this is the conditional probability that you are trying to calculate. This conditional probability of A given M is probability of A and M, or M and A, does not matter how you say that, because both events are happening together, right. Either you say M and A or A and M divided by probability of M. Once again, probability of A given M is probability of A and M divided by probability of M. What is this? What will be this probability? This probability will be probability of A given F, right. What is the probability that given the fact that the candidate is female, what is the probability of event A happening? What is the probability of event A given that event F has already happened? So what is this? This is the joint probability of admissions being offered and the candidate being a female candidate. What is this 0.2? 0.2 is the marginal probability that the candidate is a female candidate. Okay. So that is how you calculate conditional probability. Conditional probability is calculated as the ratio of joint probability divided by ratio of joint probability and marginal probability. So conditional probability is a ratio of joint probability and marginal probability. Similarly, you can calculate the other conditional probability, which we have already done, right. So this is what we have said, already said this, right. So this is the conditional probability. Similarly, you can calculate the conditional probability of admissions offered being made given the fact that a female the candidate is a woman candidate, right. That, as we said, is going to be 0.15. Now what do you do to answer the question of discrimination? How do you answer that? Now you compare only the conditional probabilities. Here probability is 0.3 and here the probability is 0.15. What are these two probabilities? This, what is this 0.15 probability of? This is a probability that an admission offer will be made given the fact that a candidate is a woman candidate. That probability is 15%. However, what is this probability? The earlier joint probability 0.3, what is this? This is the probability that an admission offer will be made given the fact that the candidate is a male candidate. That probability is 30%. So what do you conclude? How do you conclude? You say that probability of admission offer given that the candidate is male is 0.3, which is twice of 0.15, which is the probability of admissions given the fact that the candidate is a woman candidate, right. So once again, we are always going to say that conditional probability does not prove discrimination, it does not prove, right, but there may be some support to the argument, there may be some support, right. We may have to do further analysis, but there may be some support to the argument, but we are very clear that conditional probability does not prove discrimination. Okay. As I said earlier, this was a data from a sample of 1200 candidates. Maybe if we collect more data, we can be little more sure, right. Therefore, we are never going to argue that we have proved discrimination, but there is some support to the argument and we are going to leave it at that. Okay. So, this is how you use conditional probability. Now, let us talk about the broader implication here. What did we do? Let us go back to the first table. Okay. Once again, let me remove all this. Let me remove all this scribbling so that we can talk clearly. So, here we essentially had two variables. What were the two variables? There was one variable about gender, right. There was one variable which was about gender. So, this was gender and the other was admission status. Okay. We can argue that these are categorical variables where categories cannot be ordered. How do you put male first and female? You could have put female as a first column and the male as second column, does not matter which way you put, right. So, this is categorical data where the data can be put only into, the data has been put only in two categories, right. So, we have used two values for the variable called gender. We have put two values for the variable called gender, male and female. We have put two values for the variable called admission status. Admission status is offer made or not offered. These are the values that this categorical variable can take. So, essentially whatever we have done is towards determining any association between these two categorical variables, gender as the categorical variable, admission status as a categorical variable. Okay. And we have our conclusion was that there seems to be some association between the two random variables, some association. Okay. So, once again what have we achieved? We have been able to determine association between categorical variable gender and categorical variable admission status. For the categorical variable admission status, this variable takes on two values, one was A and one was AC, those were called A and AC, right. Offers being made can be one value, not offered being the other value. Gender was put up in two categories, male category and the female category. Alright. So, and then we used conditional probability to determine the association between these two categorical variables. Right. Hope this is clear, and this is the very simple explanation of categorical variable and application of that in determining the association between categorical variables. Okay. Sorry, this was a small example of conditional probability and conditional probability being used to determine the association between categorical variables.